Okay, so picking up where we left off in class today, we were basically looking at this problem right here. A rock is thrown vertically upward from the surface of the moon at a velocity of 24 meters per second, and it reaches the height of this many meters in t seconds. So we established that the velocity, which is the derivative at that point, is going to be 0, correct, for the ball. And we found that the rock's velocity at that time is 24 minus 1.6 t. How long does it take the rock to reach its highest point? It's basically the highest point is when the velocity is equal to 0. So that means the highest point is when the velocity is equal to 0. So you set the velocity function to 0, and we found 15 seconds. So it takes the ball 15 seconds to reach the max distance. So moving on, how high does the rock go? Basically, this is asking for a distance formula, distance equation. So we are going to be using the original, the s of t function, which was 24t minus 0.8 t squared. So s of 15. So where did I get that 15? Basically the question is how high does the rock go? So if the rock is thrown, how high does it go, right? And we figured out that this is our question, is the distance, how high does it go? And we figured out that it reaches this distance at 15 seconds. So that means I can figure out the height in meters if I plug in 15 seconds. So 24 times 15 minus 0.8 times 15 squared, and that ends up giving us 180 meters. So the highest that the ball goes is 180 meters. All right, now the next part is how long does it take the rock to reach half of its maximum height? So its max height was 180. So half the max height is 90 meters. And the question is how long does it take to reach 90 meters? And which function are we using at this point? We want t. We have s of t. So that is s of t. So basically we're going to be using the original function, and we're going to set, okay, so again, the camera went black.